running SSL strip. So here, again, we kind of seen this where we're going to, again, flip our machine into forwarding mode. And we put in echo 1 proxysnet and so forth. And we saw this in the YouTube video as well. But basically, that's going to be the steps of going through and setting up your IP tables to redirect traffic, right? Run SSL strip, and then run ARP spoof, right? Type snare, and then voila, everything should start working for you, hopefully. Now, what you can do is combine techniques with a homograph tag. And here, you basically what you do is you register a domain, like whatever you want there. Get a domain validated SSL wildcard certificate, and use the IDN valid characters that look very similar to the slash and the question mark, and then create false URLs. And here we have man-in-the-middle HTTP and swap out the HTTP links. And again, it's one of those cool things that we can do, and kind of take it into something like that. Basically, they're just words with different pronunciations, meaning, and origins, and so forth sometimes too when it comes to some of those. So here we can see some of that, right? So that right there becomes this right here. And we've probably seen some of that in some of the emails we've gotten and things maybe, possibly, that we're getting in and so forth. So here we can see what certificates may look like here. Right, so we have subjects of our dskdirect.bg kind of thing. You can see here, right? Looks all official, right? It's green. Green's good, right? Green's always good, right? But then again, it may not be as official as one might think when it comes down to it. Okay, other things to look into is the certificate enrollment request. And I do have one more little demo or video thingy, animation I can maybe take you guys through when it comes to certificate enrollment stuff. And we'll see if that actually holds true to what we're doing. So what I'm now here, the PKCS number 10 describes the format of your CSR. And the CSR here, in this case, contains information that clients request to be included within their certificates. Again, we've mentioned the subject name, a copy of the public key in this case, a challenge password, which could be optional, any certificate extension requests, such as your key usage, extended key usage, subject alternate name, universal principal name, and then also a fingerprint of the requested as well. So, but anyways, you could check out some of that. Just do a sample on PKCS number 10 and what that actually looks like, as in the format of it, and so forth as well. Okay, so anyway, so you can see that here, all good, and hopefully it's still not too confusing for you guys. But as you can see here, we have also distinguished names and such along with that. So keep it here. In most CA implementations, all but the common name is going to be ignored. So the common name is actually only one piece in the subject. Your abstract syntax notation 1, ASN1, is a standard and flexible notation that describes rules and structures for representing, encoding, transmitting, decoding data, telecommunications, and networking in computer networking. The formal rules enable representation of objects that are independent of machine-specific encoding techniques, and the formal notation makes it possible to automate the task of validating whether a specific instance of data representation abides by these specifications. So in other words, software tools can be used for the validation and so forth as well. Now, there's going to be many types of string types supported. One of the most common is going to be your ASCII string and such. And also common name attributes in the distinguished name are going to be encoded as described in your book there of your X502 common name scenarios and so forth. It's also, as far as your X509 is concerned, you can look up the RFC 5280. The contents of the DN name, as in your distinguished name elements, are irrelevant beyond quality comparisons, which means that you can put whatever sequence of characters you wish, as long as you do so consistently. RFC 5280 mandates case-insensitive comparisons for your UTF-8 encoded elements, name elements in this case, and this is not easy in the general contents of Unicode and so forth. You can also look at section 7.1, which links to RFC 4518 and RFC 3454. Also, the common name is a frequently displayed to the user, at least on the systems using the X509 certificates, which have the display and a physical, which have a display and a physical user. So you probably want to use the string which is meaningful or at least not too scary for a human, and you may try to avoid non-Latin scripts. Putting the DNS name in the common name attribute is common practice for HTTPS server certificates. You can look at RFC 2818, where the server certificates contain the server name, which the client matches against the server name in the URL, and normally the subject alternate name extension is preferred for that, but the common name is somewhat more widely supported by your clients. Okay, and that again was kind of taken straight out of your book there. So here we can see our common name encoding. So essentially here the CN field is represented as a Pascal string, and this is going to be different on how the C strings are represented. So you can see here how that would be represented one or the other. Okay, so we have your OXD, hexadecimal representation, and the /0 on our C string scenario. So here we also see our PKCS10 subject, common name. So that's what it would look like, right? So we have our amazon.com/0.mile2.com in this particular case. Signing requests. In the eyes of most SSL implementations, the certificate is completely valid for Amazon in this case. So those questions are, what are most SSL implementations? Well, for web browsers, it's going to be Firefox, IE, Chrome, and so forth. For mail clients, Thunderbird, Outlook. Chat clients, like Pigeon. We have AOL Instant Messenger kind of thing, right? Things like that. SSL VPNs, Microsoft NSS, MS Crypto APIs, and so forth. And if the user checks with view certificate, the C code clears out the rest and then comes across as legitimate. The only disadvantages here is that the target attacks are kind of lame. We just got word that the RDP let's see. All right, so phishing attacks are time-consuming and too much work to prepare. Right, you cannot get certificates for just any websites like eBay or whatnot. Right, so only eBay can purchase the certificate in this case. So predicting the location people visit on the web is going to be extremely difficult overall. But overall, though, sometimes it's not too hard, right? Remember, I gave you guys the banking example that I went, the social engineering tech that we did. And what I did is I went out and then I purchased the name of the bank, and the only difference was it was spelled with a C instead of a K. And again, so sometimes it could be something as slight difference like that that could make the biggest difference for you as the attacker. Very nice. So we also have what's called universal wildcards that we can use. So in this case here we have like our asterisks that we can use. It's even better to having even better than having a CA cert, because the CA cert you will need to continuously create and sign other certificates. With this, you can actually send it over and over again. So it also supports the tilde instead of the null character as well. And this is also can be defined from the Common Vulnerabilities and Exposures 2009-2408. Now, some other things could be, for instance, so you can have the asterisk tilde, which works fine. Also supports grouping. So you can have different types of grouping involved there as well. Again, pretty neat when it comes down to that. So what we've done, so what we have to worry about in this case, well, the certificate revocation. Also, right, remember we talked about that as the CRIL, also referred to as. It would be uncomfortable for if a certificate authority decides to revoke our universal wildcard certificates or if the null termination certificates. So if an SSL implementation started paying attention to how the NS1.1 is formatted, it could also cause trouble for the certificate exploit and so forth as well. Again, pretty sweet stuff, I guess, overall, right? So the certificate revocation, so these days it's all about your online certificate status protocol. And whether it's an SSL stack, which sees the new certificate, it makes a quick request to your online certificate status protocol URL that the signing CA is embedded in. The SSL stack then receives a signed response from the OCSP provider indicating whether the certificate has been either revoked or not. Now, there is a way to defeat OCSP And again, here we have the ASN.1 specification of the OCSP response, such as taken from the RFC, your request for comment 2560. An OCSP response at a minimum consists of a response status field indicating the processing status of a prior request. If the value of the response status is one of the error conditions, response bytes are generally not going to be set. You can look in your book that kind of goes over some of those OCSP responses, the status and the response bytes that it comes back with, taken straight out of your book there. Right, so there we have it. Other things, so here we have, we cannot send it successfully since we need to send the signature and so forth. So you generally don't have any include optional bytes here, so the only character that you should send in this particular case is 3 if we happen to get the response status OCSP response equals 3. So we have OCSP aware SSL sniff. And keep in mind here, SSL sniff was updated to support OCSP attacks, thus making the revocation a null prefix certificates very difficult. And again, you can kind of see a little thing there, right? Mozilla and SS null character C a SSL certificate validation security bypass, where attackers use man-in-the-middle attacks to exploit the issue. There it is. How about that? Of course, updates is going to have the auto-update mechanism, which helps the end user protect against known vulnerabilities so once a new patch has been released. So once the update has been announced to the public, companies create a new patch to fix, in this case, the known vulnerability. Okay, all right, so update aware SSL sniff. So here, additionally, the SSL sniff supports modes for hijacking, auto updates from Mozilla products, as well as Firefox, Thunderbird add-ons and so forth. The attackers can also specify payloads of their choice, which will be delivered to the targets being man-in-the-middled.